everyone, today we have AMO 2018 grade 8 question 19. So what we're gonna do is answer the question, but we need to know the question. So here it is. So continuing, we have boom. Consider an equilateral triangle. Draw the largest possible circle that is completely inside this triangle, but given the radius of the formed circle is 16 and what is the height altitude of the equilateral triangle in centimeters. I know my reading is fast, but please bear in mind and simply read the question. I will give you 5 seconds. Back here now, let's go. I have drawn this diagram which has been locked so I don't move it around. Let's analyze. We can simply draw this line from the center of the circle to the tangent point, which means that it will look like this, shown here. The center of the circle is shown in red in 3, 2, 1, boom. And it's expanding now. What we can do here is just label the lengths, I guess, 16 cm. Now, what do you think we can approach doing here? So we're trying to work out the altitude, and to work out the altitude, we simply have to find a triangle, and that triangle is, wait for it, the one I just drawn by connecting it to that. This triangle will be shaded in red. It's this one. Yay. So this triangle needs to be found. The lengths of, right? Now, it is pretty obvious, but I'll just take note. This is 30 degrees, this is 30 degrees, this is 90 degrees, this is 60 degrees, right? So now this is a 30, 60, 90 triangle. Using our old trigonometry, we find that the hypotenuse is simply double, right? So then you have 32 plus 16. Well, the altitude is simply 32 plus 16 because it's this whole, wait for it, blue line here. That's the altitude because that's equivalent to, equivalent to this. Nope, not that. This. Right, now we can simply go forward and answer the question. But we could work out the other lengths for fun. Anyway, the answer is 48 cm. And you better subscribe and like and share, by the way.